Hello, curious minds. Have you ever wondered if there could be life on moons? Then you are in the right place. First up, let's journey to the fascinating moon of Europa. It's one of Jupiter's 79 moons that has intrigued scientists for decades. This icy moon is slightly smaller than our own moon and is believed to harbor a vast, deep ocean of salt water beneath its icy shell. Imagine that. An ocean, perhaps twice the volume of all of Earth's oceans combined, hidden beneath a shell of ice. The evidence for Europa's ocean comes from a variety of observations, including the moon's magnetic field and the detection of water vapor plumes erupting from its south polar region. These plumes suggest that the ocean is not some stagnant pool, but a dynamic, active environment. The ocean is thought to be salty, and scientists believe that it may be in contact with Europa's rocky mantle, which could provide the chemical nutrients necessary for life. Think of it. Hydrothermal vents, similar to those found on Earth's ocean floor, could be spewing out heat and chemicals, creating localized oases of warmth and energy. NASA's Europa Clipper mission, set to launch in the 2020s, will perform multiple flybys of Europa, mapping its surface, studying its composition, and searching for signs of life. Who knows what secrets lie beneath Europa's icy shell? Next, we travel to another intriguing moon, Enceladus, orbiting the magnificent ringed planet Saturn. Enceladus is a small moon, only about 310 miles in diameter, but don't let its size fool you. This tiny world is one of the most exciting places in our solar system to search for life. What makes Enceladus so special? It's simple: geysers. These massive plumes of water vapor erupt from Enceladus's south polar region, blasting icy particles hundreds of miles into space. These geysers are our window into Enceladus's hidden depths. They tell us that beneath its icy crust lies a global saltwater ocean, likely in contact with a rocky core. And just like Europa, this ocean could potentially harbor life. The Cassini spacecraft, which orbited Saturn for over a decade, actually flew through these plumes and sampled their composition. The results were astounding. Cassini detected organic molecules, the building blocks of life, as well as evidence of hydrothermal activity. Hydrothermal activity, the interaction of heated water with rock, is thought to be crucial for the origin of life on Earth. Future missions to Enceladus could search for even more definitive signs of life, such as complex organic molecules or even microbial life itself. Perhaps one day we'll send a probe to land on Enceladus's surface and directly sample the plumes. Now let's journey to the largest moon in our solar system, a moon so large that it's even bigger than the planet Mercury. This behemoth, Ganymede, orbits the mighty Jupiter and holds its own as a world of incredible potential for life. Ganymede is unique in many ways. It's the only moon in our solar system known to possess its own intrinsic magnetic field, a feature typically associated with planets. This magnetic field creates auroras, similar to the northern lights on Earth, which dance around Ganymede's poles. Evidence suggests that Ganymede harbors a vast saltwater ocean, sandwiched between layers of ice. Future missions to Ganymede could use radar and other instruments to study the moon's interior in detail, searching for clues about the ocean's depth, composition, and potential for harboring life. Our next stop takes us to a moon that's truly alien, a world shrouded in a thick, hazy atmosphere, Titan, the largest moon of Saturn. Titan is like no other moon in our solar system. It's a world of methane rain, methane rivers, and methane seas, a place where organic molecules, the building blocks of life, rain down from the sky. Imagine a world where you could walk on the surface without a spacesuit, though you'd need an oxygen mask and some seriously warm clothing. That's Titan. Its atmosphere, composed primarily of nitrogen, is denser than Earth's, and it's rich in organic molecules. But here's the catch: it's incredibly cold on Titan, with surface temperatures hovering around -290 degrees Fahrenheit. The real star of the show on Titan is its methane. Methane, a simple organic molecule, exists in liquid form on Titan's surface, forming vast lakes and seas. While life as we know it couldn't survive in Titan's frigid methane lakes, scientists believe that a different kind of life, one that we can't even imagine, might be able to exist in this strange and wonderful environment. Future missions to Titan, such as NASA's Dragonfly mission, will explore this moon in unprecedented detail. Dragonfly, a drone-like spacecraft, will fly through Titan's atmosphere, landing in different locations to study its surface and search for signs of life. Our cosmic journey now takes us to Callisto, another of Jupiter's Galilean moons, and a world that has stood as a silent sentinel for billions of years. Callisto is the most heavily cratered object in our solar system, its surface a testament to the countless impacts it has endured over eons. Unlike its sibling moons Europa and Ganymede, Callisto doesn't show the same level of geological activity. Its surface is ancient, preserving a record of the early solar system. But beneath its battered surface, Callisto might be hiding a secret, a vast saltwater ocean. Scientists believe that Callisto's ocean, if it exists, could be even larger than Europa's, potentially containing more water than all the oceans on Earth combined. The evidence for Callisto's ocean comes from magnetic field measurements taken by the Galileo spacecraft, which orbited Jupiter from 1995 to 2003. These measurements suggest the presence of a conductive layer beneath Callisto's surface, which could be a saltwater ocean. Future missions to Callisto could use ice-penetrating radar to map the moon's interior in detail, confirming the presence of the ocean and searching for signs of hydrothermal activity. Our cosmic voyage now takes us to the outer reaches of our solar system, to a moon that's as captivating as it is enigmatic, Triton, the largest moon of Neptune. Triton is a world of ice volcanoes, nitrogen geysers, and a retrograde orbit that sets it apart from almost every other large moon in our solar system. Triton's surface is one of the most varied and geologically active in our solar system. It's dotted with cryovolcanoes which erupt with plumes of nitrogen, methane and other ices, creating a tenuous atmosphere. Scientists believe that Triton may harbor a subsurface ocean of water and ammonia, kept liquid by tidal forces from Neptune and the decay of radioactive elements in Triton's interior. This ocean, if it exists, could be one of the largest in our solar system, potentially dwarfing all of Earth's oceans combined. The possibility of life existing in Triton's subsurface ocean is tantalizing, though speculative. Future missions to Triton could use ice-penetrating radar to map the moon's interior, searching for evidence of a subsurface ocean and studying its composition. The extreme conditions on Triton make the possibility of life challenging, but not impossible. Our final destination takes us back to Saturn, to a moon that's instantly recognizable thanks to its striking resemblance to a certain planet-destroying space station, Mimas, the Death Star moon. But don't let its ominous appearance fool you. Mimas might just hold a surprising secret beneath its heavily cratered surface. Mimas is a small moon, only about 246 miles in diameter, but its most prominent feature is its massive crater, Herschel crater, which spans about 80 miles across. While Mimas might seem like an unlikely place to search for life, recent observations have hinted at the possibility of a subsurface ocean lurking beneath its icy shell. This ocean, if it exists, is thought to be relatively small and deep, perhaps located 15 to 20 miles beneath the surface. The evidence for Mimas's ocean comes from its wobble, a slight libration in its rotation that suggests the presence of a liquid layer beneath the surface. Future missions to Mimas could use more precise measurements of its wobble to confirm the presence of the ocean and study its properties. And there you have it, explorers, the most intriguing moons in our solar system where life might just exist. From the icy depths of Europa to the methane lakes of Titan, these celestial bodies hold endless possibilities and mysteries waiting to be uncovered. As we continue to explore our cosmic neighborhood, we're finding that the ingredients for life are more common than we once thought. If you enjoyed this journey through space and want to learn more about the wonders of our universe, don't forget to like, subscribe, and hit the notification bell. Until next time, keep reaching for the stars.